In this video, we'll discuss handling user events in PyGame. So we've already seen some of these events. We've seen the quit event, for example. Where's an example here? PyGame.poll that asks, is there an event that's currently occurring? And this poll will return the most recent event, or the next event that occurs. And if no events have occurred, it will return an event of type no event, just to signify that nothing has happened. We've also seen that these events each have something called a type to distinguish the different kinds of events. And the PyGame.quit event is just one type of event, specifically signifying the click of the X box in the top corner of our window. Now, the PyGame.event.poll is one method for determining what events have occurred, but it only returns one event at a time. If we have multiple events potentially occurring at the same time, we might end up missing or having to take multiple cycles to translate through all of those events. A better system is to use PyGameEvent.get, which returns a list of all of the events in the queue. So if 3 things happen at once, all those events get put into a queue, and PyGame.event.get will return all of them. So let's actually just create a new one here, new file, call it trails.py for a demo we're about to create. So let's set up a def main, and inside that we'll say screen equals PyGame.display.setMode. It actually doesn't matter, we don't need the variables this time. Just 800, 600 just to get it going. And we'll have a variable running equals true. And while running, events equals PyGame.event.get. Now, because get might return more than one event, we have to use a for loop to go through all the possible events and check all of them to see if they exist. So for event in events, then we ask, is it of type quit? So if ev.type equals pygame.quit, then running equals false. And notice if we use a break in this version, it's going to break out of this for loop, not the while loop. So the flag pattern that we've been using since the beginning is a rather important design choice here. It means that even though we're nested 2 loops down, we can still have a way of getting out of that top level loop. Okay. Now, before we get into using any other events, let's just take a quick look at some of the other types of events that are there. So PyGame.event.get returns all of the events in a queue, and we're going to scan through them. But there's lots of different kinds of events that could occur. So we've seen the quit event already. We're about to use what's known as a mouse motion event. There's also key down. In fact, let's go to the documentation here. So the documentation under events here, pygame.org/docs, and then click on event. Brings up all the possible things you can do with the event queue. It also has a list of all the different event types. So let's see if I can't make this a little bit easier to read. Seems a bit better. So we've seen the quit event. There's a bunch of other important ones like key down and key up for keyboard buttons, and mouse motion, mouse button down, mouse button up for moving the mouse around and clicking. Lots of other things for having joypads or changing the size of our window, or custom user events, if you will. But let's stick to the basic ones. Let's actually just take a look at mouse motion events. That doesn't take a lot to it. But one thing to point out is that every event has a bunch of attributes. So we've seen all events have this type attribute to determine what kind of event they are, but specific types of events have other attributes. For example, a keyboard type events have things known as the key that let us know what key was pressed, mod that tells us if Control, Alt, or Shift or any of those were pressed. Mouse motion has the position of the mouse, as well as any buttons that are pressed. Same with mouse button down, mouse button up. That lets us see where the mouse is and which button was clicked. So let's take a look at the mouse motion type event. So let's go back to our demo here. So if the event that we're looking at is a PyGame.quit event, then we'll set running to false, but maybe it's not. Maybe it's something else. So if ev.type equals PyGame.mouseMotion. So if it's a mouse motion event, then we can do some other stuff. In this case, we'll just print out the actual location, so ev.position. So this is one of the attributes of the events. Specifically, if it's a mouse motion event, it should have a position. So we're just going to print that out to the screen to see what's happening. And I think that's all I want for this demo so far. So let's save this and get it going. Oh, it helps if we call main. And that should be 2 equal signs there. Wonderful. Okay. So let's try this out. Python trails.py. PyGame is not defined. Oh, helps if we import things. Import PyGame, save, and off we go. Okay. So keep an eye at the bottom of the screen there. There it is. If I move the mouse around, it creates an event. It's going to create a lot of events as the mouse moves, because every time through that loop, if I've moved the mouse, it's going to report on it. So and we can see as we go to the top left here, the numbers get smaller. Toward the bottom right, the numbers get bigger. It's just going to print out the XY location of the actual mouse cursor as it moves around the screen. So what we're going to do with this is try and create a PyGame program that draws mouse trails behind where our mouse is. So the basic design is we're going to keep track of several of the previous mouse positions. So each time there's a mouse motion event, we're going to add it to this list. And we're going to keep some sort of upper bound on that list so that we're not keeping all of the mouse motions, just the most recent. So if we've gone over, if we have too many mouse motion events, then we'll get rid of the oldest locations. Okay, so we're going to store these numbers down here inside a list each time one of them appears. And then just in our animation side, we're going to draw circles for all of the mouse locations that we've seen. So let's take a look at that then. So first things first, we're going to need to have some storage for all these things. So we're going to say trail equals the empty list. And our upper bound will say trail length is, let's say, the last 100 mouse events. Okay. And now instead of just printing these mouse motion events as they occur, we'll say trail.append ev.position. So this thing here is actually a tuple. It's a pair of values, and so we can get the x and y values out of this pretty straightforwardly. But it also, this is the same information that we'll have to supply to the drawing primitive. So if we want to draw a circle, we could supply this as the x and y location representing the center of the circle. Okay, so we've appended all these things. Let's also apply our upper bound. So if the number of values in trail, so if the len of trail has gotten too big, so if it's bigger than trail length, then what we'll do is we'll remove one of the elements. So if we're appending to the end, that means the newer items are going to be at the back of this list. So what we'll do instead is trail.pop 0. We'll remove the oldest item then is at the front of the list. We'll remove that one first. So first one into the list is the first one out of the list. Now we just need to do our drawing. So this is all of this block here. Oops. All of this block here. This is all for handling events. So specifically the quit events and now the mouse motion events as well. So then next we need to do all the drawing stuff that we normally do. So start by drawing the background, screen.fill 0, 0, 0. And at the end, pygame.display.flip. Now in between those two things, let's draw our actual mouse trail. So we stored up a bunch of items inside this trail variable, a bunch of locations. So let's just go through that list of locations and draw circles at all of them. So for position in trail, pygame.draw.circle. So we're using a for each loop here where position now represents one of these pairs. Okay, and that's a tuple that PyGame can take a tuple as its value when we're drawing a circle, so we can actually just pass that straight through. So a circle needs the screen to draw to, a color, so we'll just use white trails for now, 255, 255, 255. Black background, white circles, so they should be visible. And then we just draw this position. So for each position in trail, draw a circle at that position, and let's make it radius 5. And that's pretty much it. Let's just test this out. So far nothing's happening on its own, but if I move the mouse onto the screen, we can see we get a bunch of trails. And if I get enough of these, then the old ones start to disappear and we get a cool mouse trail demo. So each one of these circles represents an event that was handled. In this case, handling an event just meant storing its location, but we can handle these events by doing all sorts of things. Maybe a click makes one of those boxes from our last demo appear, or changes everything's color. However you want to handle these things, you're going to do it in a very similar way. You're going to go through all the list of events that are occurring and look for one of the correct type. If that correct type is found, in this case a mouse motion event, then do something with that event. So use the information in that event to conjure some sort of drawing or change to our drawing so that we can look like it's responding to that event. All right. Now as a bonus challenge here, let's update this drawing a little bit and make it so that our trails fade with time. So the newest of our trails will be very bright, and the oldest of our trails will be very dark, near black. So since our trails are stored where the oldest is at index 0 and the newest is at the length of our list, essentially all this means is we need to normalize each index against the size of our list. So normalize just means turn it into a value out of 1. And then once we have that, then smaller values will have a darker color, and larger values will have a larger color, or a brighter color. So in this case, we have to change our loop a little bit. We can't use the for each loop anymore. We're going to need the actual index to figure out where in the list we're dealing with, because we have to do a bit of math on it. So we'll change this to for I in range len trail. And then we'll just say position equals trail at I. There. So our drawing hasn't changed. That should still work fine. But now let's also use this I variable to figure out what shade we should draw. Shade. Now the trick with using RGB colors is if all three channels are the same number, we're going to get a shade of gray. So if all three are at max, we get white. If all three are at 0, we get black. If all three are at the mid, which is, let's say, 128, 128, 128, we're going to get a shade of gray. If we have all of them at, let's say, 50, we get a kind of dark shade of gray. All of them at, let's say, 200, then we get a sort of bright shade of gray, but it's going to be a shade of gray. If they're all the same, then they don't have any one distinct color versus the other, so it looks kind of gray to us. Now, let's create a shade variable here that's based on this value I. We have the length of our list and this index I. So the older values are going to be near the beginning. So if I is 0, that's going to be the oldest circle in our list. So that should be drawn with a shade that's near 0. Okay, so that would be 0, 0, 0. The end of our list, that's going to be the newest one, and that should be something that's near white. So that should be 255, 255, 255. So what we're going to do is we're going to normalize this value and then multiply it by 255. So normalizing means, again, turning something into a value between 0 and 1, where in this case, the larger values near the end of our list should be a value closer to 1. So if we want to get 1 out of this list, we would divide it by the length of our list, right? So if we have I is the last value in our list, so let's assume I is the very last one, that's length minus 1, so it'll be I divided by the length of trail minus 1. Okay, so if we have 100 items and I is the last one, so that's at index 99, then this is 99 as well. So we say 99 divided by 99, we get a value that's 1. Now that should be the brightest color, so we'll say that times 255. Okay, and that's going to turn that into a shade between 0 and 255. Now, if I is near the front of our list, let's say I is 0, then we're going to say 0 divided by the length of our list. 0 divided by the length of our list is going to be a number near 0, so 0 times 255 is going to be 0. All right, what about if we're near the middle? So somewhere in the middle, I is going to be roughly half of this. Right, half the length of our list. So I divided by length of our list should be 0.5. 0.5 times 255 should be a value somewhere in the middle shade. I'm just going to make one small adjustment here, just because we want the oldest one to still appear. It shouldn't be fully 0, fully black. It should be a shade just brighter than that. I'm going to make this I plus 1, just so it's a bit bigger. And then to adjust that so we don't get some sort of number bigger than 1 here, I'm going to get rid of the minus on that side. So the largest value is now, was 99, is now 100, and this is also 100, so 100 divided by 100 is still 1. The smallest value is now going to be 1. 1 divided by 100 is 0.01, so 0.01 times 255 is a very small value. Something like 2, I believe. Okay, so now let's use that variable, shade, in all 3 of these slots, save, and try again. And you can see it almost looks like it's fading away. It's just that they're all being redrawn at every stage with a slightly darker shade as new things come in, right? If I pause my mouse, it doesn't change over time, but as the mouse moves, then it looks like they fade away. So a little bit of math to make our animation even cooler. All right, that is the end of this video.